I'm going to review how we did it, but I'd like you to also do as many as you can because that's how you get good. Here he's just trying to show us steps on solving a puzzle. I'll get to that last. Okay. This one turned out to be easier than I thought. Now, ideally, you should be able to read graphs and interpret graphs, but obviously we did too much work on this than we had to. The secret was noticing that these are all exact trigonomic figure values. Half is 45 degrees. And then you just had to put it into pi. Now, obviously, you might say, well, I'm working mostly in degrees, but it isn't a bad feature to put it into pi because 45 is half of 90. 90 is half of 180. 180 is pi. So to get from 45, since 180 is equal to pi, 45 you could just divide by 180 and you'd end up coming up with a decimal, which is fine because that's what the question's fine with. However, 45 of 180 is a quarter. So you realize that 45 is equal to pi over 4. Now you should also realize that there's going to be two values for that. So this is sine 0.5, so it's right here. So here's the 45. But then over here, there's going to be another value. Since we're dealing with sine, it's going to be 180 minus 45. 180 minus 45, which is 135. And we can come up with a fraction for that as well, because 180 is 1 pi minus a quarter pi is 3/4 pi. So that's the equivalent of 135, which is right there. And if you look, sure enough, that does look indeed like it's halfway between, and actually this graph is not well drawn because it should actually be right over here, and halfway between is indeed 3/4 pi. This one is just in the different quadrant when sine is negative, so it's still the 45, but it's down in this area, which is still going to be the same thing. It's going to be pi plus a 45 degrees, so essentially what's pi plus a quarter, which is 4 pi over 4 plus a quarter? It's 5 pi over 4. So you're going to discover it gets very easy to adjust all these figures. And then this one over here is the same situation, but it's 360 minus pi over 4. So what's 360? It's 2 pi minus pi over 4. What's 2 pi over 4? It's 8 pi over 4. Minus 1 pi over 4 is 7 pi over 4. 7 pi over 4. So you get very good at coming up with these two values just by knowing how to manipulate what they are. It would have helped right away if I'd noticed that these were all exact values. And obviously the 1 is easy to spot and the negative 1's easy to spot. It's just going to be one value. The 0.5s are 45s. And as we discovered, this one was, for sine, I believe we discovered it was 60, but you got to pull up your exact values. Once you realize that it's 60, you're dealing with the 60 and the 120, and then you can just convert those to something over pi as fractions. It's a lot easier. And then these are the same thing, but for cos, and they're all exact values again, and you just got to get used to converting. And then here is, again, the very specific question, 3 pi over 2, which is right over there. So interestingly enough, the same answer here is over there. So keep an eye out for that when you're doing questions about repeat questions and using values from other questions. How many solutions possible? 2. How many quadrants? Since it's positive, 2. 1 and 2. Determine the related acute angle. Well, I think we determined that, but you can also always pull out your exact values, sine, cos, tan, and you'll always see something useful like, I guess this one's pretty useful. There we go. And just keep a copy of it handy. And here it is. Good. And then you'll right away see that square root of 3 over 2 is over here, and for sine value that's 60, and that 60 is an expression of pi is 60 over 180, because you always just divide by 180 to find out how many pi's there are. These can be divided by 3, these cancel out. So you get 2 over 6, sorry, 1 over 3, they can both be divided by 6. 1 over 3 pi, which is 1 pi over 3, which is the equivalent of 60 degrees. But keep in mind that there's another 60 degrees, that's the 120. And then you would just have to do what's pi minus a third. It's 2/3 pi. So the two answers are 2/3 pi and pi over 3 when we're expressing it as pi. And what's the related acute angle? It's 60 degrees or pi over 3. Two possible solutions. So there you go. That's easier than it looks, I think. This next one, also the same thing, except we're solving. Now, the second one we didn't do. It just wasn't, it was tan, but it's no different. Okay. So I'm going to keep my table of values. Now, this one is using calculator. I can tell because those are not exact values. Although keep an eye out for the 0.8666. That is indeed 3 pi over 2 again. So when I look at it and I take 3 squared and divide it by 2, I indeed get 0.8660. So they're trying to be tricky. Ah, that is not an O. That's a 7. So there we go. We should be very careful. So here you got to use a calculator. You got to notice that it's negative. We're talking about cos. So you got to be aware of your CAS system again. And cos is negative, not in this quadrant, not in this quadrant, but in this quadrant. So you take your calculator, take 0.8667, and you figure out your acute angle. Why don't I use the negative? Because it's going to give me the terminal angle. So 0.8667, reverse, and we're dealing with cos, I believe. Yeah. Trigonometry, inverse, cos, 29.9222. Now, I believe it said to the nearest degree, which is unusual, because it just rounds up to 30. Yeah. So we'll put it down here. Yeah, it just rounds up to 30. Which quadrants would you find negative? We already identified that. That's quadrants 2 and 3, where cos is negative. Determine the related angle of the equation to the nearest degree. Well, okay, to the nearest degree, that's 30 degrees. We're now talking about degrees. You can see right there. And find all solutions. Well, since we're talking about these quadrants over here, we're talking about an acute angle 30 and acute angle 30. However, we always want to know the terminal angle, which is a measurement from here. So in this case, we go 180 and we subtract 30, 150. And in this case, we go 180 plus 30, which is 210. So those are the two terminal angles, 150 and 210. There's two possible solutions. Oh, determine all the solutions of the equation to the nearest, oh, that's for tan, to the nearest degree. Okay, so now we're going to go to that. And it's really the same puzzle twice. Solve, they want us to solve. So they've given us tan, right? And they've given it as a positive result. So we got to go back and review our cast knowledge for tan. So here we go. Where's tan positive? Well, always in quadrant 1 is everything positive. C-A-S-T, and over here, quadrant 3. So 1 and 3. So that would be one of the answers, B. How many solutions are possible? Well, assuming that that is not 90 degrees, there are, and it isn't because it's not an even number, there are 2 when it's positive. And sometimes there's 4 if it's a squared issue. But in this case, there's 2. So you got to take 2.7553 and inverse your tan to figure out what angle we're talking about. We're also talking about in pi's in this question. Notice the question. So this is going to give us 4.8 degrees. Oh, maybe not. So always make sure you've got a clear board. 2.7553 inverse tan. Yeah, there we go. I knew I got it wrong. Always keep multiple decimals until you reach the end. Don't round up as you go because every rounding error creates a bigger error. So, for now, I'll just look at this, and I'll pretty much just go 3. That's good. That's good enough to work with. Now, obviously, that wasn't scientific. depending on how many variables. See, they gave us 4. We should keep it in 4. But you might actually, I believe Scientific now is keeping 2 more than the one you started with until you reach the end, and then you round up to 4. It depends how many multiplications you're doing. I forget the rules for rounding. Determine the related angle for the equation. Okay, well, it's 70.75, but that's definitely the acute angle, so we got 1. But all over here is 180 plus 70, so that's 250.05. Now, here's the problem. We don't have it in pies. Now, they have to the nearest hundredth, so I don't believe I'll come up with both of them. To come up in pies, you just slam a pi here and divide it by 180. Slam a pi here and divide it by 180. And I'm going to do 2 things. I'm going to come up with the decimal that goes in front of pi. So you take your number you got here and divide it by 180. Okay, and to 4, I think they want it to 4 to the nearest hundredth, so that's the second degree. So that's 0.39. So 0.39 pi is 1. It's essentially 4/10 of a pi, or 2/5 of a pi, almost. And the other one, which is 250.0523 divided by 180 is 1.39. 1.39 seems like too much, actually. No, that makes sense. It's over 180. So 1.39 pi. Now that's in pies. So that's one way to answer it. That's in pi radians. So you'd include an answer of radians, the unit radians. But you can also take this 0.39 and multiply it by pi. And the actual radians is 1.23 radians. 1.23 radians without a pi, which is the first answer. And the second answer, 1.39 times pi, is 4.37 radians. 4.37 radians. This is the numeric version, and this is the pi version, but these are the same radian measurements. In this one, I've just kept the pi out of it, and this one I multiplied by pi, because pi is just a number. It's just a number. It's not a unit. It's not necessary. It's just a cleaner way of writing things. So this is in pi radians, and this is in just pure radians. So that's the answer to that. It's the same method over and over again for those. This one we did. I sent you the form version to correct that we did indeed have to multiply by 15 to come up with whole numbers. These, you remove the internal equation first, and then you're finding out what the angle of x is before it gets adjusted by pi. So, as an example, I'm just going to do one of them, but I think we covered them pretty well. So I'll take a complicated one near the end. So what I like to do is just remove this in the beginning and just rename it angle. Just call it the angle I'm looking for. You can just rename it whatever you want. In math, you're allowed to substitute in, and you'll actually find this a useful tool. So I'm looking for the angle. So when does this equal, when do I have that? Well, that turns out that is a exact value. So that's one of the exact values. So when is cosine equal to 3, square root of 3 over 2? Right here, that's sine, right there. So we're talking about 30 degrees. Since we're dealing with in pies, we're going to work with pies, but we can work with either for now. So we're talking about 30 degrees. However, this is positive. So looking at our cast, CA, we're dealing with these two things. So we're dealing with the pure 30, or pi over 6. And the 360 minus 30, which is 330 degrees, converting that into pi's, it would be 2 pi minus pi over 6. Well, this is 12 pi over 6 minus 1 pi over 6 is 11 pi over 6. So those are the two angles, 11 pi over 6 and pi over 6. However, now that we've solved it, now that I know it's this as one solution, and my badly written 11 pi over 6 over 12, was it? Yeah, over 12 as another solution. Now that I have my two solutions, I have to bring back, so indeed I can now say my angle is either this one or my angle is this one. And now I have to bring this back and say, okay, well, what's my x? If my pure angle is that, what's my x angle? Well, we solve. How do I get rid of that 2? I multiply both sides by 2. Cancels out here, and here it goes into the 3. So really what we're talking about is x is pi over 3, which is the equivalent of 60 degrees. So really that's what we're talking about, and it gets changed by that too. Or over here, we do the same thing. Pi over 2 is equal to this. And when I solve for 2, when I multiply by 2 on each side, I get x is equal to 11 pi over 6, because this goes into 12 6 times. So that's my actual two answers. X is equal to 11 pi over 6, or x is equal to pi over 3. And this is the equivalent of 60 degrees. And this is the equivalent of 1 pi and 5/6. It's almost, it looks like 345 degrees around there. Yeah, I think that's what it is. Oh, no, 330 degrees, I think. In any case, that's how you solve these. 300, I think it's 300 actually. I'd have to go. It doesn't matter. That's what it is in pi. So that's how you solve it. You find the angle, and then you bring this back to make these things equal the angle, and you solve for x. Because x is the actual angle on the pure scale before it got transformed by these numbers. And let's look at these transformations. Like visually, that's going to make my period half. That's going to make my period a quarter. This is going to make my period a third. This is going to make my period a quarter. This is going to make my period a half. And this is going to double my period. So all of them have been compressed except for that one. Pretty straightforward, though. Okay, we discovered that in this situation, the only way these equations can be true is when either one of these things is 0. And the way to look at it is, if I told you x times y is equal to 0, and I said, what's x, what's y? You'd say, well, the only way it can work is if y is 0, or if x is 0. That's the only way I can create a 0 as a result, which means the same thing is true for these. The only way this can be true is if sine x is equal to 0, or cos x is equal to 0. And just be careful, because as we learned, it looks like there's just two values here. However, because they included 360 degrees in addition to 0, there's actually three solutions for that. It is 0 degrees, I think it was 180 degrees, and 360 degrees. And for cosine, it was 90 degrees and 270. And since they asked our question in degrees, those are the 5 possible answers, where either this is 0 or this is 0, either one. We just set each one individually to equal to 0 and solve because of this logic. So that makes sense. When this is 0, this whole equation is 0, and when this is 0, the whole equation is 0, and they happen to be pure exact values. It's clear as you go through, that's the same sine x here. Sine x has to be equal to 0 here, or cos x has to be equal to 1. Sine x has to be equal to minus 1 here for this to be 0, and this has to be equal to 0. This has to be equal to 0, or sine x has to equal to positive square root of 3 over 2. And in case you're puzzled by those last ones, you just solve inside the bracket for 0. So let's look at this one, for instance. So it's true when either one of these brackets is equal to 0. Either one of these brackets is equal to 0. So how do you solve it? First step, add 1 to both sides. Add 1 to both sides. That gets rid of this 1 and creates a positive 1 on the other side. And on this one, when you subtract 1 from both sides, it creates a negative 1. So that's how you get rid of those. And then to get rid of the multipliers, you just divide by square root of 2 on both sides. When you divide on both sides, it disappears on the left side and becomes a denominator on the right side. So you're left with, when is sine x equal to negative 1 over 2? And when is sine x equal to positive 1 over 2? 1 over square root of 2, and that's when you go to your exact values. And you see that you're dealing with 45 degrees for just 1 over square root of 2. So the main question is, where is sine positive and negative? Well, it's all four of them. Which means we're dealing with 45 degrees here, 45 to the x-axis here, 45 to the x-axis here, and 45 to the x-axis here. Well, that's one of them. To get to this one, you go 180, subtract 45. So 45 is 1. 180 minus 45 is 135. To get to this third one, you go 180 plus 45. That's 225. And the last one is 360 minus 45, which is 315. So the four possible angles where sine can be equal to positive or minus 1 over square root of 2 is 45, 135, 225, and 315 degrees. Unfortunately, the question asks it in degrees. These are actually very straightforward because there's only so many possible solutions, and you just have to solve for each bracket equaling 0. Looks complicated, looks like factoring, looks like you have to expand and all that other stuff. You just have to apply the logic we applied in the beginning. For x times y to be equal to 0, either one of these must be 0. And we're almost done. This looks complicated. Again, it's much simpler than it appears. The secret here is to use your replacement substitution math ability. You're allowed to do anything as math as long as it follows the rule. The rules. Let x is equal to cos theta. So wherever I see cos theta in this one, I'm going to replace it with x. So I get 2x squared plus 1x minus 1 is equal to 0. I do my factoring. I know I have to come up with a number that multiplies out to minus 2, adds up to plus 1. I'm dealing with plus 2 and minus 1. I like the slip and slide method. X plus 2, x minus 1. And then I divide the units by the beginning number and simplify. So this simplifies to 1. 1, x plus 1. And this other one can't simplify, so the 2 slides up in front of the x. So the two factors I'm dealing with are x plus 1 and 2x minus 1 is equal to 0. And then I can continue and solve for x for each of these brackets using the same logic as I used last question. For the brackets to be equal to 0, x must be minus 1 or x must be at a half. At this point, I bring back my cos theta and replace the x backwards and solve. Well, looking at my, it's working in pi's this time, so always read your question carefully. But looking at your trig values, we can see that we're working with 1 over 2, which is here for cosine, so we're dealing with 60 degrees, and minus 1, or just look at the 1, ignore the minus. Or we're looking at 0 or 360. Now, the reason I got to include 360 is because 360 and 0 are included. Now, the important thing is, where's cosine negative? So let's just focus on 0. When is cosine negative? Negative 1 is right over there. And sorry, I should have said 0 degrees is my acute angle that we're focused on. The only place that cosine is -1 is right there, which happens to be 180, which happens to be equal to pi. So cosine is -1. The only answer for this one is pi. Where is it a half? Well, if I look on my chart, half is at 60 degrees, which is pi over 3. We're dealing with a positive result, so we're dealing with this quadrant and this quadrant. So we're dealing with 60 degrees here or 60 degrees here, which is 300. Well, the one easy answer is we're dealing with pi over 3 as the first answer, and the second answer is I got to figure out what 300 is in pi radians. So I can just divide by 18 and simplify. I get 30 over 18. When I divide by 6, that's 5 over 3 pi. So the other answer is 5 pi over 3. And that's 1, 2, 3 answers that can solve that. But you'll discover if you replace all of these by x and solve for x first and then bring back what x was representing, you can solve all these. Just beware of the multiple tricks and that the fact that they include this and put it in pi units after. You can convert any degrees, no matter what it is, into pi units just by dividing by 180, and you can either turn that into a decimal or just simplify it into a fraction by dividing by its common numbers. And remember to slip a pi in front of it, and the units are radians. Pretty straightforward, actually, once you figure out the basics, and that's it. But ultimately, I want you to get used to these puzzles, because this is where they're going. In these puzzles, they're describing an event that relates to a sine curve, but we're adjusting the amplitude, we're adjusting the period, we're adjusting the axis, and we're going to be adjusting, well, once the period gets adjusted, that's the toughest part. And it becomes, that becomes the internal angle that we have to solve. And you're going to need these skills. So, like, look at this one. You see this? This internal angle gets adjusted. So we're going to have to solve and like at what times is the tide at whatever 6 meters high. So you'd put the 6 meters over here. We have to solve for the equation, and once we get to the angle, you make the angle equal to this alteration, this transformation, to solve for t, because angle ultimately is in degrees, but this puzzle has changed it into something related to time, which I believe in this thing is in hours. Yeah, time in hours. So they all change the period, and you have to figure out how to solve them. And that's why you're doing these things. And that's the thing we should work towards, is solving those complex puzzles. And that's what your teacher was referring to in this. This is the steps to solve the puzzles, that there's always going to be 2 answers and that it repeats every period onwards. All right, I'm going to hang up and send this to you.